Hello, and welcome to Intro Programming and Problem Solving. As always, I'm Bart Massey, and as always, I hope you're doing well in this difficult time. Want to talk to you today a little bit about random numbers, which is a topic that actually I'm pretty interested in. I think it's fascinating, and I've spent a lot of time playing with it. I'll talk a little bit about that as we go. But I think it's important to have some basics of it under your belt fairly early on as a programmer if you're going to be really comfortable doing some of the things that we'll do not only in this class but in other places you'll be. And let's start by asking, well, what do you mean random number? That can be a really slippery thing actually to ask. There's a famous cartoon that in which the author has somebody reciting the sequence of numbers 3, 3, 3 and claiming they're random numbers. He's like, those aren't random. Well, they're as random as anything else. I mean, there's lots of definitions of random. We're going to work with sort of two ways. One is sort of by analogy. We believe that if you roll a die, a 6-sided die or a 20-sided die or whatever, you get a random number between 1 and 6 or 1 and 20. We believe that if you spin a roulette wheel, you get a random number. And so we'll say, well, things that act like that are random numbers. Technically, they're what's called uniform random numbers. Doesn't really matter very much. Another way to think about it is that these are numbers that have a limited range but are hard to predict. I know that my die will come up 1, 2, 3, 4, 5, or 6. Those are the only possible choices, but I can't guess, ideally, better than a 1 in 6 chance which one will come up any given roll. If I can guess better than that, then the dice aren't random. So that's great. Random numbers are useful in a lot of places. We'll talk about a couple of them later. But one of the real problems you run into right away is that computers are exactly the opposite of what randomness is. With a computer, if you give it a given situation, it will always do the same thing in that situation. Your if test, will always go the same way if the variable it's testing is a given value. There sort of isn't any behave randomly in Python, and really there isn't any behave randomly in the computer itself. Under normal circumstances, it's considered a bug if the computer doesn't do the same thing every time, and we try to fix that bug. That's broken hardware, sort of. And it's because it's normally a feature. It's normally great that you can count on the computer to have reproducible behavior, but not if you're trying to roll dice. So there's sort of a couple of approaches that are used for this. A friend of mine and I actually are one of many people who've built special hardware, this sort of more or less electric dice that the computer can roll to get random numbers. Of course, our electric dice are very, very fast, and that's nice because that helps keep up with the computer, but still, it's basically special hardware bolted onto your computer. Another thing you can do is you can sort of make a sequence of numbers that aren't technically random, but seem random. If I gave you the digit sequence, 1415927. Some of you might recognize that as digits of pi after the decimal point. Others of you would just sound like a bunch of random numbers, and so it'd be hard to predict. And so that's what's called pseudo-random numbers. Those are cool too. So why am I making such a big deal of random numbers? Well, first and foremost, because games love random numbers. I really, really sort of think games are a great way to engage with computers, starting from the very beginning. It's something I did from the very beginning of my computing career. And yet, there aren't very many fun games that don't have some kind of dice or spinner or shuffling. I mean, I can play chess, I can play Go at beginner levels. But, I have a lot more fun playing poker or cribbage that have shuffling. I have a lot more fun playing games that have dice and spinners and shuffling and other kinds of randomness in them, honestly. So, I really would like to have some random numbers for my games. And Python provides a function of sorts I'll talk about that in a second, to ask the computer to give us a random number, to say, well, give me a random number, and let's talk about how that works. I'm going to quit using Moo Editor at this point because I'm getting kind of burnt out on dealing with it, and I'm going to go back to what I'm familiar with, which is some combination of the Python command line and my own text edit, the text editor I normally use, Emacs. But let's start with just the command line. I can say from random import star, which is just like what we said for math earlier. It's you know, get all the stuff related to random out of that library as opposed to getting the stuff related to math out of that library. We said from turtle import star at some point. Well, now we want to work with randomness. We need the random module. And once I do that, there's this function called randrange. By the way, one of the things you can do at the Python command line is this. And it tells you that the randrange function, it tells you a little bit about what it does, but it isn't really all that helpful. Let's just try it out. Randrange. Oh, it needs a starting point. It needs some kind of range. Let's try randrange 6. Okay, a number came out. Let's try randrange 6 again. Oh, a 1 came out. Oh, this time a 3 came out. So that was why I had function in quotes back there, right? Sort of those of you who are comfortable with the mathematical idea of a function know that for a given input, a function should always produce the same output. The randrange thing doesn't do that, right? But the number it produces will always be in the range 0 to 5, which is a really annoying range. I promise you can get a 0 out of this. There's one. Why 0 to 5? Because computer people count funny. Because if you ask a computer person to count to 6, they'll go 0, 1, 2, 3, 4, 5. It's super annoying, and I've been living with it for 40 years and still don't like it, but there it is. But anyway, that's how randrange works, is that anytime you say randrange, that function will return a number that's, you know, sort of 0 to the argument minus 1, but you don't know which one. You don't know what the actual number is. You just know it's going to be one of those. So this thing acts kind of like a die, right? If I say print randrange 6 in my program, it's going to do the same thing here. It's going to print a number, but remember, it's a number between 0 and 5. So really, if I want it to be like a real die, like a physical die, then now it's a number between 1 and 6. If it was 0, now it'll be 1, and if it was 1, now it'll be 2, and so forth, all the way to if it was 5, it'll be 6. And so now I've got a 6-sided die. If I want a 20-sided die, no problem. There's a 20-sided die for you D&D players or whatever. You know, 10-sided die. I can even have dice with weird number of sides that you might never have in real life. Here's a 7-sided die. Well, how would I build a 7-sided die? That's actually kind of a fun puzzle. There is a way to do it, but there we are. So that's how you generate random numbers in Python, is you get random numbers in Python as you ask the randrange function for them. That gives you random integers at least. And so, yeah, you can do die rolls that way. But of course, a lot of games you roll not 1 die, but 2. So we can certainly do that. You know, we'll get 1 die roll. We'll get another die roll. And these are just 2 variables, right, that I'm storing a die roll in. Do I know what's in there yet? I don't. Right? I don't know what D1 got, what value D1 has, or what value D2 has. I can be confident that each of them has either 1, 2, 3, 4, 5, or 6. Let's see what we got. Oh, D1 got a 5 and D2 got a 5. Oh, so they got the same value this time. Yeah, that can happen. You know, it's not all that unlikely that it will happen. If I do it with a 20-sided die, it's less likely it'll happen. Yep, they were different this time. But anyway, let's go back to our thing where we did it with 6-sided dice. And so if I want to take two 6-sided dice, I can just roll them just like this, ask the rand range function for an appropriate thing, store it in a variable, and then I can ask, well, what's d1 plus d2? Well, apparently I rolled a 5, right? So with the sum of 2 dice, I can roll some number between 2 and 12, just like you're familiar with. But, you know, the point is we're really just simulating exactly what we were simulating before. So that's random number generation for you. That's the whole story. What if I wanted to get an arbitrary number of dice? How would I do that? So I used to play a lot of Tunnels and Trolls, which is a game like Dungeons and Dragons, but simplified somewhat. It was very popular many decades ago. And one of the things about it is it used mostly 6-sided dice, but it would use a lot of 6-sided dice. It wasn't uncommon to say things like roll 5 6-sided dice and add them up, or 12 6-sided dice and add them up, or even 20 6-sided dice and add them up. You usually didn't have 20 6-sided dice, so you'd roll them over and over. Computer can do that, right? Pretty straightforwardly. Once you've thought about for loops and while loops for a bit, you'll be pretty comfortable with how you might generate, you know, a bunch of dice, right? You can make a die roller that would roll sort of as many dice as you want of whatever size you wanted out of just this, out of just very simple Python. So yeah, for dice, for cards, etc., this is a thing. There's a lot of other cool stuff in the random library that you use less often, but that are there. So for example, if I just call the random function, it returns a number between 0 and 1, a float between 0 and 1. You don't know which one it's going to return, and each time it returns a different one. That can be useful sometimes. There's also stuff like choice. I can say random.choice. I don't remember if I can do it with arguments. I don't know if this works. Let's try it. Nah, it doesn't. It takes 2 positional arguments with 3 are given. I can do this though. And there you go. That time it chose world, that time it chose world, that time it chose hello. The curly braces, the square braces, I mean, we'll explain later. That's list notation. But yeah, the random library is full of things that are useful for doing this kind of stuff. And it's important to point out that this isn't just for games. I mean, games are great. I have fun with games, but you can also do simulations of things that happen in the real world. You can do statistical analyses. You can try to figure out what the probability of things are by doing random modeling. All of that kind of stuff is supported by random numbers. So being able to generate random numbers, really good thing. We'll talk next about building a game that has a random component in it. We'll have a homework assignment coming up soon that also has a random component in it, so I thought it was worth mentioning. Thanks much for listening as always. I look forward to talking to you again soon. Please do stay safe and well out there during this difficult time. I absolutely mean it. Take care.